All right, here we have the 3.4 notes factoring and graphing polynomial functions. So this is going to be a lot like 3.3. The only difference is now we're not going to be given our equations in factored form. We have to do that ourselves. Okay, now, anytime we're going to factor, the first thing we want to do is figure out which method of factoring are we going to use. So we kind of have this broken down here by how many terms are in our polynomial expression. And sure, we can have a polynomial with more than 5 terms, but we're not going to be dealing with those ourselves unless we're not having to actually factor it. So if we have 2 terms, first thing we always want to look for is GCF. And then if there's only 2 terms, maybe it's a difference of 2 squares. Or if it's 2 terms, maybe it's a sum or difference of cubes. So those are our options if there's 2 terms in our polynomial, like a binomial. If we have 3 terms, first always check for a GCF. And then if not, or even after we take out a GCF, it's just regular trinomial factoring. Which trinomial factoring, we want to start off by making our 2 sets of parentheses and then kind of filling in the blanks. If it's 2 terms, going back up here real quick, difference of perfect squares. Remember, that's one we're going to be using a lot. Hopefully you have that memorized by now. But if we have something in the form a squared minus b squared, that's going to factor to a plus b times a minus b. Okay, and then the cube factoring formula, we have that one written down from last unit. Well, I don't think we need to write it down. We probably won't use it on this page anyways. And then next, if there's 4 terms, we're going to do something called factoring by grouping. Okay. Now, really, this is the only time you don't want to check for a GCF first, but we'll get to that. Factoring by grouping is actually on the 3.5 notes. We're not going to see that today. This is just telling us if there's 4 terms, that's what we're going to look to use. Okay, so let's look at a few examples here. So example number 1, we want to factor negative 3x to the 4th plus 12x squared. Well, there's only 2 terms, so it's going to be either GCF, difference of squares, sum or difference of cubes, or a combination of those. So let's see. It's sum, so it's not difference of squares. Are these perfect cubes? No. So then we want to look for a GCF, which we should do first anyways. And then, yeah, we can take out a 3 out of these 2 numbers and 2 x's from x to the 4th and x squared. Now, we also don't ever want our first term to be negative. So let's take out a negative 3x and 2 x's. Oops, sorry. We can write it like that. I meant to put negative 3x squared, but this is still fine. And if I take out a negative 3 and 2 x's, then what am I left with? Well, we got x squared and then minus 4. Okay, so we factored it. We took out a negative 3x squared, but are we done factoring? Well, no, because now this is difference of 2 squares. So I'm going to change the way I write this now to negative 3x squared. That's on the outside. And then how can we factor x squared minus 4? Well, it's going to be x plus 2 and x minus 2. Because that one is difference of 2 squares. And then now we've got this thing completely factored. So now if we wanted to, we could graph it, but we're going to stop here for this problem. Okay. Next one, also 2 terms. So is this difference of squares or difference of cubes? No, but again, we want to take out a GCF first. They each have an x, so we can take out an x here. And if I get rid of an x, I'm left with x squared minus 36. Okay, now just like the last problem, now we have difference of 2 squares. So then I want to factor this thing. And then don't forget, we already took out an x, so that needs to stay on the outside. Okay, and then the square root of x squared is x, the square root of 36 is 6, so it's going to be x plus 6 and x minus 6. If you put x minus 6 here and x plus 6 here, that's perfectly fine. The order doesn't matter. Okay, and then now we've got that one factored. All right, moving on down the line. All right, next, 4x to the 4th minus 36x squared. Is that a difference of 2 squares? Yeah, it is, but we also have a GCF. Let's take that out first, because if we don't take out the GCF now, and we get 2 binomials like this when we factor this, then they're each going to have a GCF, and we're going to have to take something out of each binomial. Well, let's just take one thing out of this single binomial first. That'll be a little less work. Okay, so like I said, unless it's factoring by grouping, we want to take out the GCF first. So what do these things have in common? 4 and 2 x's, so 4x squared. And if we take out 4x squared, we're left with x squared minus 9. And just like the previous problems, now this remaining binomial is a difference of 2 squares, so we can factor that. Don't forget we got the 4x squared on the outside, and we get x plus 3 times x minus 3. Okay, and then we're done, and if we wanted to, now we can graph this thing. All right, next one here, finally a trinomial. How do we factor this trinomial? Well, anytime we have a trinomial, we want to factor it into 2 binomials. Now, don't worry about the x to the 4th. I know that looks a little different. but it's really not much harder at all. Okay. First of all, what are my signs? To multiply two numbers and get positive 36, my signs have to be the same, and they're both going to be whatever that is, so they're both negative in this problem. Then next, how do we get x to the fourth? Normally we just put x and x to get x squared. Well, what times itself equals x to the fourth? X squared and x squared. Okay, so if that's x to the fourth, normally it's just going to be an x squared here and here. Now, sure, you might think, well, what about x to the third and x to the first? That does work, but then I wouldn't have any x squareds in my middle term. Okay, so it's x squared and x squared. And then last thing, what multiplies to 36 and adds up to 13? Adds up since my signs are the same. And then 9 and 4 will work. So 9 and 4. And like the previous three problems, now we have a difference of two squares, and we have it in two places actually. So now I want to factor both of these binomials further. So this one is going to be x plus 3 times x minus 3. And here we're going to get x plus 2 times x minus 2. Okay, and now we've got all of our factors, and now if we wanted to, we could graph that polynomial. Okay, a couple more problems practicing some factoring here. All right, first one, a trinomial. The negative leading coefficient kind of gives us a hint that, yeah, we're probably going to want to take out a GCF, and we're going to want that to be negative. Okay, so do these things have anything in common? Well, sure, the numbers all have a factor of 5, and then these all have at least 2 x's, so we can take out 2 x's, x squared. So we're going to take out a negative 5x squared. And when we take out the negative 5x squared, we're going to be left with x squared plus x minus 20. Okay? Now, maybe we're done factoring, maybe we're not. We got to try to factor this remaining trinomial, though, so let's see if we can. If we can factor, it's going to be two binomials. Don't forget, we already got the negative 5x squared on the outside. Let's see, to multiply two numbers to get negative 20, one's got to be positive, one's got to be negative. Got to have x and x to get x squared. And then the hard part, what multiplies to 20, and then since my signs are different, has a difference of 1, well, 5 and 4. And then I need my bigger number to be positive because there's more positives left over, so plus 5 minus 4. And then now we've got that one factored. Don't forget, anytime you're factoring anything, you can always check your work by multiplying it back out. If I multiply this out, I should get this trinomial here. If I distribute this to these three terms, I should get what I started with there. So you can always check if you're not sure, which is the nice thing about factoring. Okay? Because it's not easy, but at least you can check your work. All right, and then the last one here, we want to factor 2x to the third minus 16x squared plus 32x. So let's see, do they have a GCF? Yeah. Each of the numbers have a factor of 2, and these things each have at least one x, so we can take out a 2 and an x, and that leaves us with x squared minus 8x plus 16. Okay. The last thing, can we factor this trinomial anymore? So let's see. 2x on the outside. To get a positive 16, I got to multiply either two positives or two negatives together, so my signs are the same, and they're both going to be negative. So minus and minus, I got to have x and x to get x squared. And then what multiplies to 16 and adds up to 8? Well, 4 and 4. Okay. So is this thing completely factored? Yes. But whenever you get a problem like this in this unit, we want to write this a different way. We want to write this as 2x times, and then I have x minus 4 twice. So then we're going to write x minus 4 squared. Okay, now is this really a whole lot different than that? No, but why do we like it like this? Well, because here it's obvious that this factor has a multiplicity of 2, which means it's going to bounce when we graph it. If we don't write the exponent, we might not realize that it bounces. Okay? So whenever you have something twice, write it with an exponent so we can identify that multiplicity really easily. All right, and at the bottom of the page here, maybe adjust my camera a little bit. All right, so this one, it says factor, then sketch the graphs of the polynomial functions, label the x and y intercepts. So now we're kind of putting it all together here. Okay, so we got y equals 4x squared minus 16, sorry, 4x to the fourth minus 16x squared. So the first thing we want to do is take out a GCF. They each have a factor of 4 and 2 x's. We can take out a 4x squared, which would leave me with x squared minus 4. And then I can factor that. That's a difference of 2 squares. So we get the 4x squared on the outside and x plus 2 times x minus 2. Okay, so how do we graph this thing now? Well, let's see. If I had this thing equal to 0, I'm going to put it on the left side because there's more room there. When is this equation going to equal 0? When either this or this or this piece is 0. So I want to see when do each of my factors come out 0. So this is going to be a positive 2, which gives me an x-intercept there, and negative 2, which gives me an x-intercept there. And that's going to be 0 when x is 0, right here. All right. Now there's different ways we can go about graphing this. Let's look at our original equation. My highest power of x is x to the 4th, and it has a positive leading coefficient, so I know my end behavior is going to be high to high. Okay, so I got that part there. And then now I just need to know, what does it do at each factor? Well, at these two factors, here and here, it's going to pass through my graph. And here, since it has a multiplicity of 2, it's going to bounce. So it's going to pass through here, come up, bounce, go back down, come back up there. So it's kind of look like a little W there. Okay. All right. They want us to list the x-intercepts, so we'll do it over here. Our x-intercepts are at negative 2, 0, 0, 0, and 2, 0. Okay, and then our y-intercept is also right there, so 0, 0. And then how many relative max or min? Okay, so let's see. Let's do the minimums first. So we have a min at, actually we don't need to say where they're at, we just got to say how many we have. So relative minimums, where do we see like a low point on our graph? Well, right here and right here. So we have 2, we'll just put 2 min because we don't have a ton of space. And then how many relative maximums do we have? So again, relative maximum isn't like the highest point on the graph, it's where it has a change in direction. So then there's 1 right here at the origin, and we have 1 max. So again, relative maximum, we just don't have a lot of space to write the word relative. Okay? And then we got all the pieces they want. All right, let's keep this note set to 1 video. We'll just roll right on through. Next page, we got 3 more examples on the back here. All right, example 3. Y equals f times g of x if this stuff is true. Okay, so f times g of x is just like f of x times g of x, which means we got negative 5x times this stuff here. X to the 3rd plus 3x squared minus 10x. Okay, so then there's our equation. So we got y equals this stuff here. And then before we can graph that, we need to finish factoring this thing. We already got it in partially factored form. I got this times this stuff, but I want to factor this stuff more. All right, so let's see. We can take out an x from this stuff here. If we take out another x, that's going to make that x squared because we want to multiply those. So on the outside, we're going to have negative 5x squared. And then on the inside, we're going to have x to the 2nd plus 3x minus 10. Okay? And then I want to factor this trinomial. So we're going to have y equals negative 5x squared. And then we want to factor that trinomial into 2 binomials. Okay, so let's see. My sign's got to be different to give me a negative 10. So one's positive, one's negative, doesn't matter the order. I got to have x and x to get x squared. And then what multiplies to 10 and has a difference of 3? Well, 5 and 2. And then the bigger one's positive, so plus 5 minus 2. Okay? Now we can graph this thing. I have intercepts at positive 2, 0, negative 5, 0, and 0, 0. Okay, just thinking ahead, it's going to go through here, and bounce here. In other words, go through here, bounce here, go through there. And then what is my end behavior? Okay, now if we look at our original problem, let's go right here where we wrote it down first. Well, if we multiplied this thing out, what would my first term be? Negative 5x times x to the 3rd is negative 5x to the 4th. So that's even and negative, so then it's going to go low to low. Okay, like we said, it goes through here and here, bounces in the middle. So it's going to go through, bounce, come back down, and go through. So it's going to look something about like that. Okay, so that is example number 3. They also said how many relative max and min do we have? sorry, just looking at something else. How many relative max and min do we have? So let's do that over here on the side. Relative maximums first. We got 1 here and 1 here, so we got 2. Relative min, we just got the 1 right there. Okay, looks like -2 and -1. I'm going to change that to a colon. Oops, sorry about that. There they are. Okay, so again, 2 relative maximums here and here, 1 relative minimum right there. All right, 2 more to go. Example number 7, this time they want f minus g of x, which is f of x minus g of x. F of x is 3x to the third, minus g of x is 18x squared, minus 24x. Now be careful, because if I write it like this, well, that's not quite right. They want f of x minus all of g of x, so we got to put these in parentheses. Okay, and then when we distribute that negative, we get 3x to the third, minus 18x squared, plus 24x. Okay, because again, we got to distribute the negative to everything in g of x. Okay, so be careful there. So then here's our function, and then we want to factor and graph that. Okay, so let's see, we got y equals, and then first thing we want to take out is a GCF. These all have a factor of 3, and they all have an x, so we can take out a 3 and an x, which leaves us with x squared minus 6x plus 8. Okay. Next, we want to factor that trinomial, so we get y equals 3x times, and then we want to factor this into 2 binomials. My signs are the same, and they're both negative. Got to have x and x to get x squared. And then next, what multiplies to 8, and then since my signs are the same, adds up to 6? Well, 4 and 2. Doesn't matter if you put 4 and 2 or 2 and 4. The order doesn't matter. But now I've got all of my factors. So then I want to see, when does each of these 3 factors equal 0? That's going to give me my x-intercepts. So that's going to be at 2, 0, 4, 0, and 0, 0. Okay. All right, let's see. Looking at our full equation. So let's look at this one here. Here's our full polynomial all multiplied out. Our leading term, our biggest x value, is x to the third. Our biggest exponent of x, I should say. So then this is an odd degree with a positive leading coefficient. So then our end behavior is going to be low to high. So I know it's going to go low to high. And then since these all have a multiplicity of 1, it's going to pass through, pass through, pass through, and I get a graph that looks something about like that. Okay, and then how many distinct x-intercepts do we have? Well, I've got 1, 2, 3 distinct x-intercepts. So then we're just going to put big old 3 right there, and then we're done. Okay. All right, so the hardest part about these problems is definitely the factoring. If you're good with the factoring, the rest is pretty easy. Okay, definitely factoring is something you get better at with practice. Let's do this last one, and then we're done with these notes. All right, example 4, we got f minus g of x, which means f of x minus g of x, which means negative x to the fourth, minus whatever g of x is, which is 4x to the third, plus 4x squared. And don't forget to put it in parentheses, because now I need to distribute that negative. So we get negative x to the fourth, minus 4x to the third, minus 4x squared. Okay, let's take out a GCF. They all have a negative, and they all have at least 2 x's. So we'll take out a negative x squared. And then don't forget, this is my function, so we can put the y equals there. So we get y equals negative x squared is the GCF we're taking out. And if we do, we're left with positive x squared plus 4x plus 4. Okay. Next, we want to factor this trinomial. So we get y equals negative x squared times, and then I want to factor that into 2 binomials. I know my signs are the same, and they're both positive, so we'll start with that. I got to have x and x to get x squared here. And then what multiplies to 4 and adds up to 4? Well, 2 and 2. Okay? But since I have the same factor twice, I want to write it a different way. I want to write this as negative x squared times x plus 2 quantity squared. Okay? Now I can see that it's going to bounce at this intercept and it's going to bounce at this intercept here. Where are my intercepts at? Well, it's 0, 0. And at negative 2, 0. Okay? All right, and now what's my end behavior? So let's see, looking at our full equation right here. We got negative x to the fourth as our highest power of x. So it's even and negative, so I know it's going to be low to low. And then it's going to bounce here, come back up, and then bounce back. So it's going to look something about that. Okay? And then how many distinct intercepts, x-intercepts did we have? Well, just 1, 2. So just the 2 x-intercepts. Okay? All right, and then that wraps up the notes. So again, if you're good with factoring, this shouldn't be that hard. But, you know, factoring is tough. Anyways, that's it.